So, students, today we discuss about the another part of reflection of light, which is known as total internal reflections. Okay, total internal reflection. In this case, in this phenomenon, we get some of the phenomenon which is to happen. Suppose mirrors, looming, and glittering of diamonds, optical fiber. These topics, that means these phenomena are related with total internal reflection. Okay, so when we discuss about the reflection of light, we know when a ray of light travels from rare medium to denser medium, অর্থাৎ লঘুতৰ মাধ্যমৰ পৰা যেতিয়া ঘনতৰ মাধ্যমলৈ লাইট ৰে এটা মুভ কৰে, when a ray of light travels from rare medium to denser medium, then refracted ray bend towards the normal. Okay, other way, if the ray of light travels from denser to rare medium, then the refracted ray bends away from the normal. Rare to denser, refracted ray bends towards the normal. Denser to rare, refracted ray bend away from the normal. Okay, so in this phenomenon, that means in total internal reflection, in this phenomenon, the light ray must be travel from denser to rare medium. Okay, so we know light ray bends away from the normal when ray of light travel from denser to rare. So here we see, here we consider two medium. So this is rare medium whose refractive index is mu1, and this is denser medium whose refractive index is mu2. So this is an object which is considered at the point O. This is an object. So ray of light travels from the point O. Okay. So in this case, here we consider 4 rays. That means 4 incident rays. But all the 4 rays, what happened? Okay. So here the angle of incidence is gradually increases. That means angle of incidence gradually increases. মানে আমি আপতন কোণটো ক্ৰমান্বয়ে বাঢ়ি বাঢ়ি গৈ আছে। ঠিক আছে, if the angle of incidence is gradually increases, then angle of reflection is also increases. Okay, so here in first rays we consider, in first ray, this is first ray, second, third, and this is fourth. So in first rays, the light rays moving in this direction, that means refracted ray. Denser to rare medium, ray of light, so refracted ray bends away from the normal. Okay, so in second case, this angle of incidence is greater than this angle. Okay, so this angle of reflection is also greater than this angle of reflection. Okay, that means previous one, like this. So this angle of reflection is greater than this angle of reflection. Why? Because this angle of incidence is greater than this angle of incidence. Okay, so in this case, that means in third rays, when the ray of light denser to rare travels from denser to rare, in third rays there is no refraction phenomenon takes place. There is no refraction. That means the rays of light, refracted ray, that means refracted ray is moving from the surface like this, moving in this direction, refracted ray moving through the interface of the two medium in this direction. So what will be the angle of reflection in this case? If the ray of light is moving in this direction, the angle of reflection is angle made by refracted ray with the normal. So this is the normal and this is refracted ray. So this angle is this, that is 90 degree. This is 90 degree. Okay, so for this angle of incidence, I, the angle of reflection becomes 90 degree. So for which angle of incidence, in denser medium, the angle of reflection in rare medium becomes 90 degree. That angle is known as critical angle. Critical angle, সংকট কোণ. So here critical angle, this is angle of incidence. So angle of incidence, so it is I, but it is critical, so it is denoted by C. That means I C, critical angle IC. Okay, so what is critical angle? The angle of incidence in denser medium for which the angle of refraction in rare medium becomes 90 degree. That angle of incidence is known as critical angle. Okay? So next case, in fourth rays, what happened? Here, the angle of incidence is also greater than this angle of incidence. Here also, the angle of incidence greater than this angle of incidence. So here, there is no reflection takes place. In this case, all the rays of light come back to the same medium. That means all the ray of light come back to the denser medium like this. Okay, so we know. So when a ray of light travels from, when a ray of light come back to the same medium, this phenomenon is known as reflection of light. So here in force rays, the ray of light come back to the same medium. Okay, that means reflections phenomenon takes place. So this phenomenon is known as total internal reflection. So why it is known as total internal reflection? Here all the ray of light, come back to the same medium. That means reflected towards the same medium. All the ray of light. Okay, so this phenomenon is known as total internal reflection. So what is total internal reflection? If the angle of incidence exceed the critical angle, then all the beam of light come back to the same medium. This phenomenon is known as total internal reflection. Okay, so in this phenomenon we get two conditions. That means this phenomenon will takes place for two different conditions. That means conditions must be satisfied. Okay, so first condition, light ray must be traveled from denser to rare medium. So light ray must be travels from denser to rare medium. Orthat light ray to ঘনতা মাধ্যমৰ পৰা লঘুতা মাধ্যমলৈ মুভ কৰিব লাগিব. First point. Second point, the angle of incidence must be greater than the critical angle. Angle of incidence must be greater than critical angle. We get two conditions. First one, light ray must be travels from denser to rare medium. Second point, second condition, the angle of incidence, this angle of incidence must be greater than the critical angle. ঠিক আছে? So in exam, সাধাৰণতে আমাৰ অলৰেডি এক্সামত কিনেকুৱা ধৰণৰ কোৱেশ্চন আহি গৈছে, আজি 2 বছৰ আগতে CBSE আহি গৈছে, তোমাৰ এই ৰেগটা দি দিয়া আছে. These rays are already given. So what happened in reflected ray? That means এই ডায়াগ্ৰামটো কমপ্লিট কৰিব আছে, 2 মাৰ্কছ আহিছিলে. ঠিক আছে? আৰু কেতিয়াবা তোমাৰ এইটো কি আহে, what is critical angle and what is total internal reflection, সেইগিটা বিষয়ে ডেফিনেশ্যন লিখিবলৈ আহিব পাৰে. ঠিক আছে? Then আৰু কিছুমান কোৱেশ্চন আহিব পাৰে. So write the conditions in which total internal reflection phenomenon takes place. ঠিক আছে? So এনেকুৱা ধৰণৰ কোৱেশ্চন ইয়াৰ লগত ৰিলেটেড আহিব পাৰে. ঠিক আছে? এতিয়া আমি total internal reflectionৰ ক্ষেত্ৰত, এই ফেনোমেননৰ ক্ষেত্ৰত আমি যদি Snell's law to apply karo. তোমাকে পাইছা Snell's law of reflection, second law of reflection, sin A by sin R equal to mu. আমি আগৰ ক্লাছত অলৰেডি কৈছো, গতিকে sin A by sin R equal to mu. That means this known as total, Snell's law. So his Snell's law যদি আমি ইয়াত apply কৰো, তোমাকে চাবাচোন কেনেকৈ আমি Snell's law to apply কৰো. So this is ray of light travels from denser to rare. Applying Snell's law, mu 2 sin I c equal to mu 1 sin 90 degree. Applying Snell's law, mu 2 sin I c equal to mu 1 sin 90 degree. So sin I c equal to mu 1 by mu 2. means equal to 2 mu 1. Light ray travels from second medium to first medium. So it is 2 mu 1. So this sine IC equal to 2 mu 1 equal to, according to the principle of reversibility. Already last class we get principle of reversibility. 2 mu 1 equal to 1 by 1 mu 2. 1 mu 2 sine IC. So from this we get sine IC equal to 1 by 1 mu 2. From this formula we can determine the critical angle. So here we get, from this we get critical angle. IC equal to sine inverse 1 by 1 mu 2. Okay, so this is the total internal reflections. Gotike ইয়াৰ লগত related আমি numerical পাম. গতিকে numerical খিনিৰ ওপৰত যদি আমি চাওঁ তেতিয়াহলে আমি গ্লাছ আৰু অলৰেডি ৰিফ্লেক্টিভ ইনডেক্স জানো, গ্লাছ আৰু এয়াৰ, ইয়াৰ ক্ষেত্ৰত যদি আমি ডিসকাস কৰিবলৈ যাওঁ সেইটো চাই লওঁচোন তোমালোকে। এই ডায়াগ্ৰামটো তোমালোকে ভালকে ড্ৰ কৰি লবা, ঠিক আছে? আৰু মই যিখিনি কথা কৈ দিছো সেই কথাখিনি তোমালোকে নিজে লিখি লবা, ঠিক আছে? একদম ইজিকে কৈছো, বুজি পাবা, ঠিক আছে? আমি চাওঁ এতিয়া আমি কি ইউজ কৰিছো, গ্লাছ আৰু এয়াৰ। গ্লাছ আৰু এয়াৰ ক্ষেত্ৰত যদি আমি এপ্লাই কৰো তেতিয়াহ'লে আমি গ্লাছ আৰু এয়াৰ ক্ষেত্ৰত যদি পাইছো গ্লাছৰ ৰিফ্ৰেক্টিভ ইনডেক্স উইথ ৰেসপেক্ট টু এয়াৰ কিমান পাইছিলো আমি, ৰিফ্ৰেক্টিভ ইনডেক্স অফ গ্লাছ উইথ ৰেসপেক্ট টু এয়াৰ ইজ ইকুৱেল টু 3/2, that means 1.5. So here sine IC equal to 1 by, here in between glass and air, which is denser medium? Air and glass. Glass is denser medium, air is rare medium. So light must be travel from glass to air. Okay, so sine IC equal to, okay, লিখিলা না ৰহাই দিছো। এনেকৈ আমি উলিয়াব পাৰিম IC equal to sin inverse 2/3. এই ভ্যালুটো আমি ক্যালকুলেটৰ মাৰিব লাগিব, এই ক্যালকুলেটৰ তুমি এই ভ্যালুটো ক্যালকুলেট কৰি চাব পাৰিবা, ঠিক আছে? সো গ্লাছ আৰু এয়াৰৰ মাজৰ ক্ৰিটিকেল এংগলটো সাধাৰণতে কিমান হয়, 41.8 ডিগ্ৰী, ঠিক আছে? আমি এইটো ক্যালকুলেটেড ভ্যালু এটা পাইছো, that is 41.8 ডিগ্ৰী। তোমাক যদি কেতিয়াবা সোধে যে গ্লাছ আৰু এয়াৰৰ মাজত ক্ৰিটিকেল এংগল কিমান, that is 41.8 ডিগ্ৰী, ঠিক আছে? সো ইয়াত এনেকুৱা ধৰণৰ কোৱেশ্চনটো দিব পাৰে, কি বুলি দিব পাৰে, the refractive index of glass with respect to air is 3/2, so find the critical angle, ঠিক আছে? আকৌ এটা আমি চাওঁ, গ্লাছ আৰু ৱাটাৰ, refractive index of glass is 3/2 with respect to air, and refractive index of water is 4/3 with respect to air. So in this case, which one is denser medium? Glass is denser. Okay, so glass light ray must be travel from glass to air. Okay, so another question. Second question. If refractive index of glass with respect to air is 3/2 and refractive index of water with respect to air is 4/3, find critical angle. Critical angle. Okay, so in this case, which one is rare medium? Glass and water. Which one is rare? Water is rare and glass is denser medium. So Solution. Applying Snell's law. Mu z sine IC equal to mu w sine 90 degree. So this is easy method. Sine IC equal to mu w by mu z. Sine 91. So it will be 4 by 3 and it will be 3 by 2. That means 8 by 9. So IC equal to sine inverse 8 by 9. So this is the answer. Okay. So these are the topics related with total internal reflections. So next class we discuss about the related topics in which case total internal reflection phenomena takes place. Okay. So thank you.